Now, if you kind of think about it for a few minutes, and you may want to pause before you hear my explanation, you can figure out that this is actually less likely to happen than just each of them individually. So if you wanted to know what's the probability that you roll a six-sided die and you get a 6 and then a tail, well, that's less likely than just getting a 6. You kind of have to be more lucky. You have to roll the 6 and get a tail. Okay, so we're going to first create a tree to find our probability. So when we roll the die, we could get a 1, 2, 3, 4, 5, or 6. And then off of each of those, we're going to put the possibilities for flipping the coin. So off of each of those, we could get a head or a tail. So the probability of getting a 6 and then getting a tail. So if we count all of our possibilities here, we see that there are 12 possible outcomes. And there's only one place where we rolled a 6 and then we got a tail. So that would be 1 out of 12. Now, just notice the probability of getting a 6, well, there are two ways that we could have, let me do this, say in red. There were two ways where we got a 6 in the head and then a 6 tail. So that'd be 2 out of 12. And tails, well, 1, 2, 3, 4, 5, 6. There are 6 out of 12. So this is the same thing as 1/2. Before it would have been 1/6 for the P of 6. And notice you could have just thought about rolling the die or flipping the coin in either of those situations. And notice if you take 1/6 times 1/2, we would get the answer we saw here of 1/12. So our next one, it says, get a number less than 5 and then get a head. So how many are less than 5? Well, we're going to circle these possibilities, I guess, in green. So we could get a 1 and then a head, a 2 and then a head, 3 and a head, or 4 and a head. So that would be 4 ways out of the total possible 12. So that reduces to 1/3. Now, if we're just talking about the dice, less than a head, less than a 5. There are 4 things less than a 5 out of 6 possible things you can get from a die. And for heads, there are 1 way out of 2 possible outcomes for a coin. And again, 4 out of 6 times 1/2 would give us 4 out of 12. Okay, we're going to do one more. Probability of getting an odd number and then getting a tail. Sorry, this is getting really, really messy. I'll do it in purple. So an odd number and then a tail. So we could do a 1 and a tail, a 3 and a tail, or a 5 and a tail. So that would be 3 out of 12 or 1/4. So the probability of getting an odd number, well, you could get a 1, a 3, or a 5. So that would be 3 out of 6 if we're rolling a die. And the probability of getting a tails is 1/2. So again, notice if we multiply those two probabilities, we would get 3 out of 12 or 1/4. So you might be seeing why we call this the multiplication rule. So before we get into actually using that rule, we have one more definition we're going to have to use. So that's the definition for independent events. So we're talking about independent events when you have 2 events that you're doing back to back. You're doing one thing and then you're doing the other. So the definition goes, given a random procedure, 2 or more outcomes or events of the procedure are called independent if the occurrence of one, so the occurrence of the first, does not affect the probability of the occurrence of the other. So if two things are independent, then here we have what's called the multiplication rule. So the probability of A and B, we would do the probability of A times the probability of B. Now you do have to make sure the two things are independent. And things will be independent. Rolling a dice, flipping a coin, whatever happens the first time does not affect the second time at all. We'll see cases in a minute where things are not independent. So this procedure says roll an 8-sided die 4 times. So each time you could get the possibilities 1, 2, 3, 4, 5, 6, 7, or 8. So first we're going to find the probability of getting a 6 all 4 times. So another way of saying that is you get a 6 the first time, and a 6 the second time, and a 6 the third time, and a 6 the fourth time. Now the probability, these would all be independent. If you roll a dice, it doesn't matter what you get the first time. It does not affect the probability the second time. So rolling a 6 the first time would have a 1 out of 8 probability. So times for the and. The second time, again, we'd have a 1 out of 8 probability. Times the third time, we'd have 1 out of 8. And the fourth time, we'd have, again, 1 out of 8. So multiplying these, we'd get 1 over 8 to the fourth, which is 1 over 4096. Now, if you do this, put 1 divided by 4096 in your calculator, you're going to see it might say 2.44, and then you'll see an e to the negative fourth. Now, it's just important to know that this is scientific notation, and this means you're going to move the decimal 4 places. This e to the negative 4 means move the decimal place 4 places to the left. So we'd have 0.000244. So those two things just mean the same thing. So the next one says, what's the probability you get a 2 all 4 times except for the third time? So get a 2, then get a 2, then get anything but a 2, and then get a 2. So the probability of getting a 2 would be 1 out of 8. Probability of getting a 2 again would be 1 out of 8. The probability of not getting a 2 would be 7 out of 8. There are 7 other possibilities. And the probability of getting a 2 would be 1 out of 8. So when you multiply this, we'd get 7 over 8 times 8 times 8 times 8, which is 4,096. So question 3 here says the probability that a person in the United States has type B blood is 1.5%. So as a decimal, this would be 0.015. 3 unrelated people in the U.S. are selected at random. So we're going to, since there's so many people, we're going to assume that this is an independent event. So part A says, what is the probability that all 3 have type B blood? So this would be the first person has B, and the second person, and the third. So this would be P of B, and B, and B. So we would take 0.015 times 0.015 times 0.015, which would be the same as 0.015 to the third power. And when you put this in your calculator, it may say 3.375 e to the negative 6, which means we'd move the decimal places 6 places to the left. So we'd get 0.00000. If we round to 3 significant digits, we'd have 338. Now, the next one says, what's the probability that none of them have type B blood? So we'd want the probability of not B and not B and not B. Now, If type B blood is 1.5%, not B would be 1 minus this, 0.015, which is 0.985. So we'd have 0.985 times 0.985 times 0.985, which in our calculator gives us 0.956.